Hi, I have a face. Okay, good. I'm gonna turn off my sound on my phone. All right, hi. What do we got today? Who's first? We got a midterm coming up, so I assume we'll have some questions on that type of stuff. Austin, go ahead.
This is a really quick question.
Yeah.
So all like the extending of lecture 9 is out of scope?
Yeah. Lecture, we're only going up to last Friday. Yeah.
That's all.
No extends, no casting, no higher order functions. Because you, unless you were ahead on the project, have not had any practice yet. That's the usual philosophy. All right, what's next? Happy to do things from lecture today, old midterm problems, whatever. Seems good. Waiting. This is my most extended silence of all live Q&As. Let's see. Okay, I mean, yeah, if anybody have anything? I guess I can talk about random stuff. Generic midterm review. Sure. Let's see. What would I want to say? Yeah, well, here's some high-level ideas then, and then feel free to jump in after I talk for a little bit. I mean, syntax-wise, there's all this basic Java. Oh, I need to share my screen. Not that one. All right. Okay. Screen sharing has failed to start. Would it be worth my time to handwrite everything from the reference sheet from fall 2020? Nope. We have our own reference sheet. I mean, you could, but I wouldn't do it. All right, finally, there we go. Okay, sorry, screen sharing was failing to start. Here we go. So we got that basic Java syntax all covered in homework 0. We had project 0. You know, basically what this did is it talked you through helper methods and how to decompose problems. Then we had our testing lecture. So hopefully you've written some JUnit tests and thought about that. And we, of course, had the lab. So, you know, we have the testing. Testing will definitely be on there. And then really just, I think the main content is 4 through 8, where we have all the stuff you did in Project 1 Checkpoint. Like I always like to write my first midterm for this class. Like I like to do it very early. And I like it to be based on this project, to basically that the linked list deck and the array deck are your practice for it. Because I think that that's the most interesting, like it brings everything together, right? You get all the syntax, you get all the data structures thinking, you get just a tiny bit of, you know, performance. We haven't really gotten to, you know, rigorous analysis of algorithms yet, but you get the sense that there are fast ways to do things and slow ways to do things. So yeah, I mean, that's the story basically, that I really feel like Project 1 is the best, or the Project 1 Checkpoint at least is the best practice. That's my very high level generic review. Let's see. All right, I got a request. Okay, first thing, method selection puzzle. Okay, let's see. Is that today or yesterday? Oh, I need to make link the 2021 version of these slides. Okay. So this is slightly, someone asked about this puzzle, I think. Hold on, let me see. Is the person who just asked me on the chat, is this the one you had in mind? All right, cool. So, you know, casting's not in scope for the midterm, but nonetheless, I still think that it's an interesting problem to think about. So we'll have to, this one's a little harder than what you might find on the midterm, but that's fine. That's what we want to do a slightly harder problem. Okay, so the goal is decide whether dog.bark is called, show dog.bark is called, or there's a syntax error, and the declarations are show dog has a method bark that overrides the method bark of dog, and of course dogs are objects. So if we look at this first line, okay, maybe what I'll do, I'm going to make a copy of this slide. The way I solve this problem is I always think about my variables dynamic types and static types. So I'm going to make a little table. There's room for it to fit. Okay, I'm going to have a variable. Why did I make so many row columns? I didn't need them. Okay, so we got, I'll do variable or expression. Okay. Here I'm going to have static type. I'm going to have the dynamic type. Okay, so let's do it. I'm just going to do this problem without asking for feedback from you guys. I hope that's okay. I just think that I find it a little tedious to do this kind of problem with back and forth. Maybe it's a good idea, but online at least it feels strange. So we got O2. All right. So what is O2's static type? Well, it's based on the declaration, which is object, right? Like that's the static type. It's just like, because that's how it's declared. And then its dynamic type is show dog, because that's what's new over here. Now, question is, a show dog an object is the next thing I think. Yes, it is, because a show dog is an object. Therefore, there's no compile error. So I'm going to put a little check mark here. That's fine, no error. Okay, next we have SDX. Well, I know I just said I wasn't going to solicit feedback, but anybody want to chime in on what the static type of SDX is? Yeah, show dog, right. And so it's show dog, and that's because that's how it's declared. So we're only looking at the left-hand side. In fact, to drive that home, if if I had, spilled something on my screen and this was just completely blocked, I would still know that it's show dog. I don't even need to know it's over here. Like that is not important to understand SDX's static type. Its dynamic type is, well, all I need to know is that O2 somewhere in memory is pointing at a show dog. So in this case, what I'll say is that this cast here is entirely irrelevant. It has no impact whatsoever. It's redundant. Okay, so it's just there to make you think, huh? Oh, actually, though, let me add a new line. Let's say I did show dog SD live equals O2. Okay, so if we did that, actually, I'm gonna check mark. So I'm making a new line of code here. SD live, its type is show dog. And the issue here, though, that we'd run into is that when the compiler looks at this line, what's it going to do? Maybe one way to think about what the compiler is doing is it doesn't know what happens when code runs. So the compiler's view of the world is like this. Like it sees, like it doesn't know what's over here, I guess is what I would say. So from the compiler's point of view, what's it going to say here? Crash, yeah, a compiler error. It's going to be mad because it just sees there's an object O2 and someone's trying to put it in a show dog box. The compiler doesn't know these things, right? That's all stuff that happens at runtime. Okay, makes sense. Could you write a compiler that actually looks at it and thinks about the types? Sure, but the Java compiler doesn't. Yeah, compiler.bark. All right. So because it doesn't know that O2 is a show dog, I mean it is, right? But it doesn't know that, so it's going to play it easy and it'll say no, not good. All right, so I'll take that away. So this cast right here, despite what I was saying a moment ago, it is necessary so that this line compiles because the compiler doesn't know the type of O2 because it doesn't do this kind of type inference. You could build a Java compiler that does it, but then your compiler is more complicated. So it doesn't. It doesn't like try to think ahead and say, oh, well, it actually says new show dog, so I know that it's actually going to be safe. You have to do this. The compiler is dumb on purpose. Now we get to SDX.bark. Okay, so SDX, it's static type. So what I think about it is that static type is show dog, and show dog has a bark method. Right here it is declared. We know that it's part of this class, and so this is the one that's going to get called. It's going to call showdog.bark. So this is no surprise. It's going to be showdog bark method because it's overriding the superclasses. If the show dog didn't actually declare this method, like it didn't override, if it was like that, it would call the dog method instead of the show dog method. All right, we got dog equals dog O2. Again, that's fine. I guess I'll do some types here. We got DX. Static type is dog. What's the dynamic type?
So also dog.
Yeah, right. It's dog. Good. Oh, uh-oh. One person was incorrect, though. So I'm going to pick on you, if you don't mind. Let's see. Right. OK, cool. So it's show dog. Good. So what does this cast do? It just says compiler, don't worry, this object's actually a dog. You can do it. Now I'm going to call dx.bark because this object's static type is dog. Which method's going to get called? Show dog's bark or dog's bark? What do you think? Okay, I got some private messages. So you're right, with people who responded, it's show dog's bark. And the reason is that the dog class, yes, it's going to call a method called bark, but show dog overrides it. So our rules for dynamic method selection are, first we figure out what signature. So the signature in this case is bark. And then we use the dynamic types bark method. So the dynamic type is show dog. So we're going to use the dynamic types bark method. So step 1 is, and step 2 is use show dog's bark. Okay. All right. here the the method signature doesn't have any parameters. It's just the name. So why does the dog not make the dynamic type a dog? So the dynamic type is the type of the actual object. So another way of thinking about this, let me make a copy of the slide. Do I have actually this code in a way that I can run? No. Okay, I'll draw it myself. So if we think about the memory boxes here, we have object, or I have O2. No, I'm going to grab something from a previous lecture, okay? The very clearest, best diagram. Oops. Okay, one sec. This visual picture is super important, so I'm stalling this out for a good reason.
Thank you so much.
Okay. Wait, what did I just do? Okay, cool. So I'm gonna grab this whole thing. So in this universe, we have O2, SDX, DX. Static type is show dog. This one is object. This one is dog. Okay, and this is dog, show dog, object. And they're all pointing at the same show dog, who could be a fox. Okay, so crucially, all three of these memory addresses are the same. They're all the same 64-bit address of this object. And so when I say the dynamic type, I'm talking about the dynamic type. They're all the same thing, right? Like this thing right here, if I look at it closely, look how handsome it is. This is a show dog. Like the fact that this is Mortimer Corgi 25, 5, 12, 2, 2. Like these are his attributes. So he has his own memory boxes that I'm just representing in this text format. I guess I'll bullet point him. He's that important. Okay. So all the attributes of the object are shown here. He is a show dog named Mortimer, who's a corgi, has these two numerical attributes. And so this dynamic type is just like what Mortimer is, right? So if I can't change this. Like this object is a show dog. That's my answer to you, Noah. Does that make sense, Noah? So in other words, the dynamic type is the type of the object. It's not some special property of the variable. It's the type of the thing.
Yeah, that makes sense. Thank you.
Yeah, cool. Very subtle point, but a really important point. Any other questions about this? All right, I'm gonna come to your question in a sec, Ryan, after we wrap up the exercise. Okay, so we go back to this part here. We're gonna get show dogs bark. Okay, now we do dog O2 bark. So in this case, my expression is dog O2. Okay, so what is dog O2's static type? Anybody wanna? This is where we have to know casting. So if you're behind on lecture, this won't make any sense. But what's the static type of this expression? Dog, right? And the dynamic type is show dog, because again, it's just another one of these things. Now I have another box that's, doesn't have a name, but it is just the same old thing. So I guess I'll write it on the side. So this is dog O2. So what I'd like to observe is like it doesn't change anything at all. It's just like a different reference. Oops, sorry. It's just a different reference to the same old object with the same dynamic type, of course. But the static type is just given here, right? So that's how I think about this thing. Oh, and also it points at same object. There you go. All right, cool. So this line then, whenever it runs, it's going to say, does the dog class have a bark method? Yes. So we're going to use the dynamic types because it overrides it. There you go. So it's show dogs bark. And then we get to the very end. We got object 03. We got to add one more row. Okay, we got 03. What's its static type? Okay. What do you think? All right, yes, it's object because that's how it's declared. This cast over here doesn't do anything at all. This one's totally useless. Okay, so whenever we get to 03.bark, so this line executes just fine. But when we get to this line, we get an error because of the fact that an object does not have a bark method. So here, object does not have bark. And if that seems mysterious to you, remember again that the compiler is not thinking about the right-hand sides of these expressions. So as far as the compiler is concerned, it's this. It says object 03 equals something. Please bark object, but we don't know what it is. Okay, any questions about this exercise? Cool. Great, I'm glad to hear it. Private message person. Yeah, go ahead.
Yeah, so when does a runtime error occur right now? Like, for example, if we call this 03.bark, is it gonna have an error during runtime or during
Compilation time? Yeah, so it's a compile error.
Okay.
Yeah.
So in what cases could we have like a runtime error?
Sure. So an example of that would be if we do, say I'll write a piece of code that does this. Okay, I'm going to take away all this stuff up here. And so some code that would cause an error would be object O equals new, or let's see, sorry, dog D equals dog new object as an example. That would cause a runtime error. So what the compiler would do is it would see the following. Like it's like, someone's trying to assign the results, or like it's trying to put a dog in a dog box. So the compiler is going to be totally okay with that. Like the types line up perfectly fine. But then at runtime, when this actually happens, it tries to cast an object as a dog, but an object is not a dog, so it'll be a runtime error.
Oh, okay.
So that's an example of a runtime error.
Okay, thank you.
Okay, let's see. I'm going to go back to Ryan's question, then I'll do your question, Brian. So Ryan no B. The compiler picks the method signature and sticks with it based on static types. Yes. So effectively, there's no such thing as runtime overloading. The only thing that the dynamic types would affect is a potential override. Yeah, I would say there's no such thing as runtime overloading. Right. I kind of get what you're getting at, and no. So the only thing the dynamic types impact is a potential override. That seems like a fair statement to me to make. The thing is, like, I don't know that the phrase runtime overloading is, like, I don't know 100% what you mean by it because it's not a thing. But I think the basic idea you're getting at is true there. All right, if casting only impacts static type, how is it that it still ends up picking the correct dynamic method for stuff? Like if we cast a string to an integer, right, okay, yeah. So the question was, let's say we have the string hello, and then we do integer x equals string s. And then we call something specific to an integer, like x dot, let's grab something from integer class that's clearly a numbery integer class. Okay, let's do float value. No, that's not very fun. Number of leading zeros. Okay. Well, that's not static methods. None of these are very interesting. Okay, whatever. Float value. Okay. Oh, of numbers too. Okay. So let's do 35. Okay, so suppose you do something like this. what this will do is, well, what you might think it would do is that at compile time, it will say, oh, well, oh, sorry, cast wrong, I should say integer. So you might think, oh, what it'll do is it'll say, oh, well, this is really an integer, so this is fine. And that there's something under the hood that happens that casts this number 35 as an integer. But actually what will happen if you try and write this code is this cast will fail. So I haven't mentioned this in class, but basically, because the, all right, I'm gonna add yet another new slide and take away all this stuff. Get rid of all this. So if we have two classes that are like so, here's string, and here's integer, and here's object. This is just the inheritance tree. Java will actually check and observe that because of the shape of this inheritance tree, there's no way that that a string could be an integer, that they're sibling or that they're cousins in the inheritance tree, right? So it's not that there's no direct line of descent from one to the other, right? Like an object could be an integer, but a string could never be an integer. Or like a I'll show you, I'm going to unveil more of the secret tree that I don't teach you in this class. So there's also this thing called number. There's many different types of numbers: floats, floats, doubles, integers, shorts. So because of the inheritance tree, like if I have something that's of type number, so I should say this cast will cause a compile error. Okay. And so again, I'm going a little beyond the scope of the class, but I think it helps us understand the stuff that is in the scope. So let's do it anyway. So if I do number x equals new integer 500. Actually, I can even do double. If I do double x, sorry, int x equals, it's going to use all the capital letter versions of the classes. C equals integer x. Okay, so we do this. This cast is okay at compile time. And well, there's no cast. This cast is okay at compile time because it is the case that a number could be an integer. We don't know, but the compiler will allow the cast at compile time. Anybody want to guess what this code will do at runtime? Sorry if I took you out onto a crazy world, but good question. I actually don't know. I think it'll cause a runtime error, but let's try it. Okay, I'm gonna open IntelliJ. Okay, so the code compiles just fine. When we run it, it fails. Okay, yeah. Double cannot be cast to integer. Let's try doing some primitive types. What happens if we do this? I bet this will work. No, can't do it. Interesting. Okay, hold on a sec. I'm a little surprised by that one. Let me try something. So that works. This doesn't work. Oops. All right, so these reference types, this is not super important stuff. I'm just kind of curious. Okay, yeah. So that doesn't, you can't cast from the, this is funny though. Hold on a sec. This will work though. Ha, okay. Anyway, all right. This is perhaps a little silly, but yeah. So if you have something in a, this is the kind of thing that a bad class like mine might teach you, is like the rules for all this. But it would be such a bad use of your time to learn this. Anyway, so that you know, this cast is okay at compile time. I'll say this. Josh wasn't sure what it would do at runtime. It's a little weird. Okay. let's see. Yes, go ahead, Austin.
Hey, I had a question for a past exam.
Yeah, one sec. I want to say one more thing, and then I'll be happy to take it. So earlier, the person who asked, like, what happens if you do a cast like this? I want to prove to you also that this will just not work. If I try this, the cast causes a compile error. And if you look at it, it says, cannot cast string to integer. Just not allowed, because it's impossible that a string could be an integer. Okay, any other questions on this? Yeah, can't cast siblings, or I would call them cousins, because you can't cast a number as a string either. So not exactly siblings, they're like cousins. Okay. Yeah, let's see. Okay, I'm gonna answer the question I just got on the Zoom chat real quick, and then I'll come back to you, hand raiser. So someone asked, for questions that involve JUnit tests, can we assume that an equals method exists? And I would say, no, you shouldn't assume that an equals method exists unless it's specified. So I wouldn't do like assert equals array_dec x array_dec y and assume that works well. Yeah. Yeah. Let's see. Don't do this sort of thing unless we say array_dec has an
I'm
equal.
not sure you can see.
Oh, there you go. I'm putting it in Zoom. Zoom chat. I don't know why I put it in Zoom chat, because I usually do it in a notepad window, but my ways are mysterious. Okay, so Austin, go ahead.
Yeah, I had a quick question on Spring 16,
Okay.
on 6C.
Yeah.
So
6C midterm 1. Berkeley. Okay, spring 2016. Midterm 1. 6C. Okay. Yeah. All right. Oh yeah, this one's really hard.
So yeah, it's kind of a long question, and pretty much most of it made sense except for that for loop. That's what kind of tripped me up.
This
And so I
for
looked
loop
at
here? 6C. C. Okay.
yeah, and
Right.
the filter method.
Mm-hmm.
So inside that for loop, I looked at the answer key and like tried to work it back, but I thought it might be more beneficial like see you thinking it out.
Okay, sounds good. So what we're trying to do, let's see if we can all understand the problem quickly. We have original message, and our messages are in arrays of characters, okay? And then we have a list of banned characters, and it's, let's see. Okay, right, so it has to be invariant to rotation too. Okay, so if someone does DDOGBA and we give them the word bad as banned, then we should get back dog. Okay, we got DDOGBA. I see what this is getting at. So this is building off array_dec, the idea of like a wraparound strings. So then banned is OG, so we should get DDBA, and bad to dog, bad gets just that part. Okay, I got it. One quick thing I want to do, let me see if this is there's one exam where we left off a line, and so it ended up being a lot harder than we meant, or something like that. So I'm just gonna cheat real quick. Let's see if it's that. So I'm ready psychologically. Oh, hey, it's Alice. She broke her arm in an arm wrestling match right after she graduated. FYI. I was like, you guys are hardcore doing arm wrestling matches that actually break people's arm. Anyway, it was a different time, I guess. Okay. Wait, why is this the right exam?
I added the answer key in the chat if it helps as well.
Okay, cool. Right. Okay. Yeah. So we slightly messed up on this problem. That's what this thing is. This is very hard. So it was a little harder than we anticipated. So let's note that first. Okay. This is, I think, the hardest midterm problem we ever had because of that issue, where because we didn't have enough lines, you had to like do this sort of insane thing all at once. So I'm going to cheat and violate the line limit a little. Is that okay?
Yeah.
I don't want to do it the way, because it was, I don't remember what exactly happened, but yeah, I remember it was a big bummer. Okay, so
If you're typing on the
And-
screen, I think it's
Yeah,
still
I'm
on.
setting up something. Okay, here we go.
That's good.
Thank you. They always remind me though, because obviously it happens. I watched a pretty funny video where a guy at a university in Singapore accidentally did a 2-hour math lecture with nobody able to hear him. Which made me laugh a lot. All right. Okay. Okay, so, and what helper methods do we have available? We have match start. So first of all, a little tip, if part C says you can use parts A and B, they're not always useful, because sometimes they're just there, pedagogically, or like testing your ability to do things, but let's see, match start and matches. True if the message matches starting at K. Okay. Does, and then okay, got it. All right, so matches was useful for writing match start. So I think this is the one we actually care about. We basically have the ability to say where a match starts. So we want to filter out, can the word occur more than one time? Do you know?
I think we just have to, yeah, it says somewhere that like it only appears once.
Okay, great.
Yeah, it appears once, if at all, yeah.
All right, sounds good. Okay, so I'm just going to walk through it as I would solve it. And I'm not doing this I'm doing it not soliciting input, because I'm thinking maybe my problem solving approach might be useful. So this is a hard problem. And what I need to do is, okay, so I'm just thinking, I got some structure here. I can tell we're trying to, so num to copy, this says to me I'm supposed to use this part of the code to figure out how many characters to copy. So for example, I guess I'll bring this down here. In this example, the num to copy would be 3, right? This one, num to copy would be 4. This one, it would be 6. Okay, that's what I'm thinking here, just because that's just how the code problem seems to be set up. So I need to use this all here to set up num to copy. This is going to be a new array that is the number, that's going to be the return message. So actually, I think I can immediately just say the result array is going to be num to copy. It's like how many things I need to copy over. And this code's just supposed to be copying things over. Okay, so this is the copying loop. This is the computing what the num to copy is, but there might be some funny thing going on here. The fact this return is here makes me think recursion could be useful, but on the other hand, this is an array method. And since it's an array method and I can't just like, like I have this creation in the middle, it seems pretty unlikely that the solution to this would be recursive, because I don't really have a way to like track the current state. It's not like I have a, I can't just keep calling this method over and over with some piece of information that changes and it's static. So it's not like my filter. So I don't think it's recursive. This is something else. It seems to me that this is probably if the banned word doesn't exist at all, because then I don't need to copy anything and I can just copy the original message. So that's my working assumption. I'm going to try and fill it out that way. So I haven't seen this problem, by the way, in years. So I'm doing this totally cold. So if match start, oh, I messed up a detail here, which is that, I would say if there is no match, oh yeah,
-1.
-1. Okay, so if match start message, oh wait, okay, so I have a thought. Wait, so match starts -1, return message. But I actually also care about the match start. So I think I want to assign it to a variable here. So I'll call this int ms for match start. And if ms is equal to -1, then I return. All right, I feel pretty good about this. So I know where the match begins. If it's there, if there is no match, I return message. Otherwise, I need to do num to copy. Okay, so num to copy is how many characters in the array I'm returning. So if I started with 6 characters and I match, well, the match is always going to be the length of band, because we're taking out exactly the string band only one time. So that seems pretty easy. to me, as someone who's taught this class 7 times, 8 times maybe. But it seems like it should be message length minus band length. Let me double check that though. So message length in this top example is 6, and band was 3, and 6 minus 3 is 3, and this thing's length 3. So by tying out that small example, I know I'm not off by 1. Okay, so now I need to copy everything. So they forced me to start with I equals 0, and for that I am grateful because I don't have to think like, oh, I need to start I here. I'm just going to start it in this beginning position and then iterate along. Message index. Okay, so I need to do result I equals, right? So they're telling me I'm going to fill in the message starting from the leftmost character of the like. Is that right? Well, that's the natural thing to do. I guess you could do it the other way, but I'm going to assume that I can use this index as the index into what I'm returning, and then I'll return result. Okay, so in other words, I am deciding to use I as the index into the result array. And the reason I'm doing that is because the word message index implies that it's the index into the message where we're starting. So if I do, for example, ms, then that would mean I'm going to start copying from that point in the message, but I don't want to do that. I actually want to start after the message. So I think it should be ms plus band.length. So that would be here, 1, 2, 3. Okay, so for example, in example 1, or in top example, that's 1 plus 3 equals 4, which is the B. That seems great. Okay, let's check the other ones. So in Dodogba, we're looking for og. We're gonna do here. This is message. This is band start. This thing's linked 2, so it'll go 2, 3, 4, which is the right place to start. Okay, and then dog. If we do band bad, then again we go here and we start here. Okay, so that's where I'm gonna start. Now, all of these examples don't actually involve. Oh, actually, you know, this first time I messed up. The band word was bad, not dog. Sorry. In top example, that's okay. Top example. I'm gonna be more explicit here. This is the top example. So for this example here, ms is the match start, which is position 1. Okay, num to copy is 3. Message index. No, sorry, match ms is not 1. What is ms? 4, thank you. So the message index is going to be 4 plus the band thing length right here, right? Because we're skipping that, equals 7. Okay, so that's, the index is off the end. And I had the sense that this could be a problem. So what I need to do is actually mod this thing by the, and because I don't want to mess up the order of operations with mod, I'm just going to throw in some extra parentheses because no reason not to. So I'm going to mod this whole thing by message.length. Okay. So if I do this, that's going to give me 1. Is that right? We just wrap back around to a bad place. If I see 4, 5, 6, 7, mod 1 is here. Dog. And dog is what we want. Okay, yeah, so this looks good. Looks good. So reflections, even if you're not 100% following my chain of thought, because I'm just thinking out loud, notice that I'm like taking specific inputs that have been provided for me, and I'm trying them out. I'm plugging in numbers, making sure that they like match semantically what I expect. Okay. So far I feel pretty good that I'm on a great track. And again, reminder, I've taught this class 7 or 8 times. So this just comes way lower friction for me than you. So when I is 0, we're going to go I less than num to copy I plus equals 1. And again, that's because I have decided that I is the index into the result array. So what I'm going to do is fill in the return array, which we call the result. So I'm filling it in like it starts off as null, or not null, null. I'll call it x, x, x. So it goes from X to D, X, X to D, O, X to D, O, G. All right, so that's the way I'm thinking about this thing. And so this code right here is going to do it. Now I just need to put the correct thing on the right-hand side. Okay. So now I need to do, so result I is going to be equal to message message index. So I'm going to start by copying 1, and then I'm going to do message index equals message index plus 1. Oh, but we have a little issue here. Wait, message index plus 1. But again, I need to keep in mind that the array could wrap, so I really need to mod this by message length as well. Okay. So I know it's wrong because of that issue we talked about earlier, where the solution doesn't look like this, and this seems too simple. So there's some bug here, but this is very close to the right answer. The only reason I know there's an error, if I had not remembered from years ago that there's some subtle issue here, I would probably call it a day here, and I'd feel like, I got it right. But let's just see how the code runs if I do this. Okay. Oh, not message. Yeah, result. Okay, yeah. So result. This is what I expect to happen. So the first time through the loop. All right, maybe I would do this on paper, not actually in Notepad window, of course. But okay, so first time through the loop, I is 0. Message index is 1. And result is nothing. Okay, and the change that happens is that result I gets set equal to message 1, which if I look at message 1, which is right here, it's D. So result becomes D X X. Okay. Next time through the loop, I is 1, message index is 2, result was D X X. We say result 1 equals message 2. So result becomes D, and then if I look at message 2, that's 0, 1, 2, it's O, so it's O. Looking pretty good so far. And I can just tell by symmetry that's just going to work out. So for this example, it works fine. So it's got to be some other example where it breaks. Okay. Let's see, each iteration of the loop. Okay, so there's some subtle issue, and the case I haven't really fully thought about is where the banned word actually spans the, oh no, actually, where the thing we're copying spans the edge. So bad. This one doesn't do it, the dog. Okay. This one doesn't either. I'll make up a new input.
The second example works with, I think, the edge case you're going for, where the outcome.
Oh, this will make my code break?
Yeah, the second doc test will break, yeah.
All right, sweet. Okay, let's see it break. Cool. So by the way, I think that when we graded this, the answer we have so far was, I think, all but 1 point on the problem, or less. Maybe it was even like half a point.
I got verbatim what you were right now. I knew it was a problem, but I couldn't figure out how to resolve it.
Right. Yeah. So it's very hard. Okay. So let's try and do it though live. I'm going to do it by fixing one line, like adding another line, but then eventually I'm going to also go over the way we did it in the line constraint. What we're doing on time. Okay. We'll do just the added line. All right. So let's see it break. So in this case, if that's message, so ms match start is 0, 1, 2. Num to copy is 4, and the message index is going to be 4 plus 2 mod 6, which is 0. Okay, cool. Oh, I see. The issue is something in the middle. It's in the middle of a message, I guess. All right, something like that. So message index is 0. Okay, so then each iteration is the following. I equals 0. Message index is 0. Result is nothing, 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 nothing. We do result 0 equals message 0, okay? Return, aha, I see what's gonna happen here now. Return becomes, or sorry, not result. Okay, so we'll do one more that's like the easy, everything's working fine case. Result 1 equals 1. Okay, so now we have D. 2 message index 2. All right, this is where it's going to break. Then it does result 2 equals message 2. And that's not supposed to happen. This is banned text. So we end up copying over the, oh, okay, bad. Okay, that O is supposed to be gone. Okay, that's actually a really interesting problem. So how do we fix this? Okay, so now what I'm going to observe is it is really hard if we're using I here as the index into our result to like somehow skip in the middle. So I'm thinking actually I shouldn't be the index that we're using as the index into the result array, because it's just very awkward. Like if you do this, you have to break the symmetry at some point. Like if I is the index into the result array, it needs some special discontinuity. So we could do that, right? I mean, one way is I could say, if I equals match start, okay, here we go. I equals match start. You're not gonna like this, but oh wait, hold on a second. It's message index that needs to jump. Okay. Sorry, message index is increasing by 1 each time. It needs to have some discontinuity when you reach the match start. So the way I would do it, if I, the problem, so I should make it very clear, the problem was broken when it was on the exam. It was very hard to actually solve in the space available. But what I would probably do if I was just doing an exam now, I realized this issue, which kind of caught me by surprise. So the fix that I've come up with is, well, the message index, though, it might actually need to like have a jump. So if message index equals the match start, then the message index equals message index plus band.length, but all of this modded by the message length. So basically the message index is increasing, but then it does a hop. So right here, hop over the band part of the text. Does it make sense? You happy with that?
This is
the fact
way
that
more
the-
readable than their solution. Like when you look at this, it makes more like logical sense of like what you're trying to do.
Yeah, this is the clean solution. Okay, so then let's think about the hack solution that we came up with to fit in a line when we realized that we had screwed up. So in this case, all right, so if you make the message index increase by 1 each time, you have this discontinuity when you reach the match start. So the alternate approach would be, rather than copying like we would copy starting here to here, right? Like if you start at B, the copying at B, then you don't have to worry about the message index like running over to the end. So in this case, I guess the key is that, so let's see. All right, I was gonna leave it here because I gotta run, but to arrive at the fancy solution, we'll start copying the message starting the character after the banned word. Okay, so if we do that, then I don't need to worry about message index needing a discontinuity. Instead, I'll just start here, 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 and here. And so, oh, sorry, I'm keep saying the wrong thing because I keep looking at band and dog backwards. But let's go to this example because I want to get this in our live video for anybody who might watch this later. So we want to copy starting at B, right? So And the intuitive approach that doesn't fit on the lines available, we start copying from D. And so in other words, it goes D to DD to DDB to DDBA. In the no discontinuity approach, which is much trickier, does fit, we start copying from B. So in other words, the result array goes from nothing to B to XXBA to DXBA to DDBA. And doing that is pretty hard, but that's the idea behind it. Does it make sense, Austin?
Yeah, I think that the principle makes sense.
And so getting from the principle to the actual code is something what one might call code golf. So there's like a world of programming which is not like useful, but it's interesting. So there's something called code golf, which is writing code under in the absolute minimum number of characters or lines of code. That's why it's called golf, because you're trying to get a low score. It's not a good programming practice, but there's a whole set of like techniques for doing this sort of thing. And in this case, I guess we're doing code golf on line count. And so there's a little bit of golf you can do here, where you can, let's see. Yeah, so there's sort of a double modding happening actually in here. And there's actually, well, it's funny, it's even broken out onto 2 lines. So, this is like an A++ level challenge that's kind of a puzzle. But I think the interesting part, like the part that will actually prepare you for our midterm today, or future midterms in this class, is recognizing the distinction between these 2 approaches and why this one fails and why this one is likely to succeed. But the golf part is not something I want you to learn how to do. Okay. Let's see. Okay, yeah, and there may be other approaches, by the way. Like, it may not be that you start at B, but that's what I think. I mean, you could do something like you start somewhere and go backwards. I don't know, but this is I'm guessing this is the approach that the code golf way looks. All right, I got to go to other class, but thank you, everybody, and good luck on the midterm.
Thank you.
I hope that watching me
Thank
solve this
you.
problem was interesting and useful. All right, see you.